The modern audio mixer has detached from the physical control surface. A rigid box of faders now operates as a network-connected control platform. Integrators no longer evaluate high-end audio systems simply by counting input channels. The critical metric is how seamlessly the system can be automated, monitored, and integrated into a broader production environment. Achieving this requires a structural separation known as decoupling. The digital signal processing, the engine actually routing and mixing the sound, is entirely separated from the user interface. The dMix 128 operates as a control-first platform, prioritizing network-centric architecture over the traditional model of a hardware desk with remote add-ons. True ecosystem integration means abandoning the concept of a single primary hardware console. Control must shift to a central, networked processing brain that treats all interfaces as equals. In modern live environments, operation is rarely isolated to a single person. Multiple technicians, automation scripts, and monitoring applications require simultaneous access to the mixer's parameters. State confusion occurs in legacy digital mixers when multiple remote applications attempt to simply mimic user interface actions without a shared reference. For instance, a monitor engineer adjusts a feed on a wireless tablet, and the tablet registers the channel as muted. However, the main console at front of house still displays that exact same channel as active. Superficial remote control protocols break down under the stress of concurrent multi-client parameter updates because they are fighting the mixer's own internal software for authority. Without a single authoritative state reference, complex audio ecosystems experience data collisions. Synchronization fails during critical show moments because the system lacks a unified model of truth. Open Sound Control, or OSC, solves this by providing an open-ended communication protocol. It allows disparate network devices to dictate precise instructions to the mixer. An OSC message pairs an address path, like /channel1 mix fader, with a numerical value, like 0.5. This explicit command forces the fader to the halfway mark. Network transport determines delivery. A rapid flow of data utilizes UDP on port 10,023. UDP offers low latency, making it the preferred choice for fluid user interface gestures, where a single dropped intermediate packet goes unnoticed. Conversely, critical one-time commands utilize TCP on port 10,024. These messages move as discrete, locked payloads. TCP provides reliable delivery and framing auto-detection. This guarantee is mandatory for actions like a snapshot trigger, where a single dropped packet ruins a show sequence. Supporting dual transport protocols lets system integrators align their network methodology directly with the risk profile of each specific audio command. The dMix 128 system treats OSC as a peer to every other syntax entering the network, maintaining a strictly protocol-agnostic architecture. External protocols like OSC, QRC, and ECP are ingested by dedicated protocol daemons. These translation layers strip formatting to output a uniform data shape. This universal language maps parameters on a 0.0 to 1.0 scale, later converting into native audio units like -10 decibels. Normalization allows generic controllers to address the mixer seamlessly without calculating internal DSP mathematics. Mapping functions use precise benchmarks. For example, a 0 dB fader position translates to exactly 0.7647 on the normalized decimal scale.
By utilizing daemons and mathematical normalization, the architecture separates the external controller's language from the mixer's internal audio processing, ensuring universal compatibility. Once the command is translated and normalized, it travels deeper into the software stack, arriving at the internal key system. This directory tree maps every controllable parameter in the dMix 128 to a specific .delimited string. An input channel becomes i.0.mix, and an aux bus is addressed as a.2.mix. Exposing deep object classes directly to the network allows integrators to bypass the graphical interface and target granular processing functions. An external system can target specific commands, adjusting EQ band gains or triggering individual VCA mutes. Legacy systems artificially restrict third-party control. They expose superficial faders and mutes, but lock down the deeper routing and processing. The dMix 128 internal key system is exhaustive. It encompasses aux sends and multi-band compressors, snapshot isolation parameters, and system metadata. This dot-delimited architecture exposes every internal function as a searchable object for external systems to address. All of these translated keys converge at the central key store. This memory bank is the ultimate destination for parameter updates and the definitive engineering solution to state confusion. This in-memory mirror enforces deterministic state. It acts as the single authoritative reference for every external protocol operating on the mixer simultaneously. Sitting behind the key store is a bidirectional WebSocket engine, broadcasting real-time state changes. When a new client connects, an init process downloads the complete mixer state via synchronized key value pairs. During operation, if a value alters, identical update packets instantly push to all connected peers. The central key store ensures that every connected device operates as a synchronized peer, observing and updating a single, unified mathematical model in real time. Zooming out from the software stack, we can observe how this unified state model executes in complex hybrid production environments. In a theater setting, a media server like QLab uses TCP over OSC to fire complete snapshot recalls perfectly timed with pre-programmed video cues. Concurrently, a musician on stage uses a custom touch OSC layout over UDP to rapidly adjust their personal monitor mix without interrupting the show control logic. In an installation environment, this schematic shows how a custom wall panel restricts volunteer users to approved parameters like speech mics and master volume, while the main matrix remains protected. Throughout all of these automated events, the front-of-house engineer retains total system visibility because their primary console interface is synced directly to the exact same key store. Ecosystem integration means specialized automation, personal monitoring, and main mix control can coexist securely without fighting each other for state authority. On the dMix 128, OSC provides a direct network interface into the mixer's internal key structure, granting external protocols the same level of control as the local interface. As broadcast and installation environments demand tighter automation, closed hardware ecosystems will become severe operational liabilities for system integrators. A decoupled protocol-agnostic platform ensures the mixer is never tied to a single user interface. It is built to serve as the central hub for any future control ecosystem.